Okay, so today we're talking about distance equals rate times time. That is really important. Write it down in your notes. And underneath it, maybe you could abbreviate it with dirt. I bet. That little equation is right up there with Pythagorean theorem in usefulness down the road. What's the Pythagorean theorem? A squared? All right. What's another big formula that you know? Quadratic, good. X equals negative, b plus minus square, root b squared minus 4ac, all over 2a. That's a big one. And there's one more. Y equals mx plus b is a biggie. Yep. Area comes in handy. It's not too hard to memorize, but yeah, length times width or base times height. Oh, y1 minus y sub 2 minus y sub 1 equals awesome. It's in there in the Hall of Fame of formulas, okay? And we haven't used it very much. By the way, this one was what? Point slope. That's point slope form of an equation. All right, so back to this formula, really, really handy. Distance equals rate times time. If I look back at my original problem that I talked about at the beginning of the hour, this one, just kind of flashed it up there quick. Notice that there are tons of distances and rates and times in it. All right, so we've got the train leaves Philadelphia at 1 p.m. What's that 1 p.m. thing? That's the time. It's traveling 65 miles per hour. What's that? All right. Another train leaves Denver at 4, and that's a time. And notice we've got this Denver and we got this Philadelphia. What do you think is going to happen with Denver and Philadelphia? A distance, yes, a distance. Like when are they going to meet or when are they going to pass each other, that kind of a thing. So that's a distance. Distances and rates and times are best combined when we do distance equals rate times time. So here is a typical problem. Do you remember Balloon Boy from the news? And Balloon Boy, the story, in case you weren't paying attention, was mom and dad have this balloon that they're going to launch for fun. They have the media there. It's like the weather balloon kind of a thing. And then they launch the balloon, and then they say, oh, crap, where's Billy? And their little son, and they said, somebody goes, oh, I saw him playing in the little box underneath the balloon. And then they say, I think he might be in there because we can't find him anywhere. Turns out that the allegations are, and I think he even pleaded guilty to it, that they had like planned this from the beginning. The little boy was like hiding in the garage the whole time. So they told everybody they thought their kid was on board the balloon, but he really wasn't. Anyway, and so the media was like covering this balloon up and, you know, flying over the countryside with the little kid in it. But people have actually done this before, for real. Except if they I don't think, as far as I know, anybody's done it to their kid. They may have wanted to do it to their kid, but they've done it to themselves. How could you launch yourself? Yes. Yep. Doesn't have to be like one of these gigantic balloons, though. The problem is that you're not going to find a balloon that big anywhere handy. What people have done, and this just happened not too long ago, a guy made a big deal about you know, he got the media there and everything. He got himself a lawn chair, put it in his backyard, and a whole bunch of tube tanks of helium, okay, because you can get that just for like blowing up balloons, right? Except he put the helium into great big balloons, like weather balloons. Not that kind of balloon, but weather balloons are like, I don't know, probably have a diameter of like 4 feet or something like that, or 5 feet. And so he filled up a whole bunch of these balloons, had his friends help him because he couldn't like hold on to them all at once, and tied them to his chair. And he just, as soon as they like untied his chair, they had his chair attached to the ground. As soon as he like released it from the ground, just took off, rose up there. And he was like, he had done this before. This was his second time doing this. I can show you the YouTube video for it later. But one guy that had done this originally, he just did it in his backyard with a couple buddies, and it didn't have the media around or anything. But he brought a 6-pack of beer and a BB gun. What was a BB gun for? Shooting the balloons. In case the balloons, like he wanted to come back down again, you just shoot the balloons. But he got so scared when he got up there. They say that you go through different versions of fear of heights. After about 10 feet, there's the first fear of heights, and that's kind of like, ooh. And then you go up past like 30 feet, all of a sudden there's a whole new fear of heights. Do you remember at Wolf Ridge when you had to go up? That's the reason that the things are at 30 feet, because there's another whole level of fear of heights at 30 feet. And then you go up like past 60 feet, and then there's like a whole nother fear of heights kicks in, and he was just scared out of his mind. I think he thought if he like shot one of the balloons, what do you think might happen? He might, what if he were to like shoot one of the balloons and like by accident hit like 4 balloons? You know what I mean? That wouldn't be good, because then he's going to come crashing down. Well, anyway. All right, so this guy, the first guy who did it, that took off with his 6-pack of beer and his BB gun, he ended up going up so high because he was afraid to shoot the balloons that, and I'm sure the higher it got, the more scared he got, that he got into the airport's air traffic area, so that the planes that were coming in couldn't go past, or they might hit him, which could cause their, like if they hit something going really fast, they could break their wing off and kill everybody in the plane and him. And so they had to close the airport for several hours until he came back down again, or got far enough away so they could open the airport again. That's like millions of dollars to close down an airport, and all those ticked off people. So anyway, don't try this at home. All right. Now, it says distances and rates and times, and my recommendation for all these problems is that you set up this little formula, D equals R times T, and you make a chart just like this. Would everybody please copy that into your notes right now? Now, we really need to take a second to read this thing. So I'd like you to all read it silently to yourself. I'll pause while you do that. And just so you know, you're not like a bad reader if you have to read the thing twice. When you're reading a math problem, it's a good idea to read it twice or even 3 times before you totally understand what's going on. Next thing, if you really want to try to understand it, what I would always do is make like a little picture, just a very simple one, of what's going on. And we've got the boy in the balloon, and I'm going to keep it really simple. I'm just going to make it like a vector. Okay, and he's going like this in the balloon. And I'm going to pause for a second here. And the boy is going this way. And where's Dad? Is he starting from, where's he starting from? Same spot. And he's going which way? Same direction. And in the end, they're going to go the same distance. You see how that it helps you to like see what's going on. So the dad and the boy are going to go the same distance. All right. So I'm going to put boy here on my chart, and I'm going to put dad here. And I need to write an equation for the both of them. A D equals R times T equation. And so I start with the distance. Does it tell me how far these guys went? No, it never tells me that. And as soon as they don't tell you something like that, you immediately can put a variable like D. All right. Next, if I don't like my D, if dad's distance is the same, what should I put for dad? D. Because if D is right for the boy, it's right for the dad too. All right. Next is rate. The boy's rate. Is it in the problem? Yes, it is. So what do I put? 20. The dad's rate. They give it to us. So what do you put? R. Don't ever change variables. If it's in the R column, use R. All right, and time. Do we know how long the boy was in the air? His time. Yes, 1.2 hours. And then dad, was dad like traveling as long as the boy was, or was his time shorter? Shorter. So I could take dad's time, 1.2, 1.2, and I could take away some amount of time, right? This is the hard part. This is where you earn your money, so to speak. Because these are all pretty easy, but this one right here is the hard part. It's not that hard, though. It's 24 minutes, so I got to change that to hours. So how do I do that? 24 divided by 60, which is 0.4, and so this ends up being 0.4. So it's 1.2 minus 0.4, which is 0.8. Put that in your chart.